The rate of return is labeled as I star. Okay, in certain cases, we can find the value of rate of return by using the present worth or the annual worth analysis. The main idea is if you borrow the money now, that is your P, you will need to repay the amount annually every year, and that is your annual series, which is equivalent to the P now. Cash that goes out at the present time should be equal to the cash that goes in, and it should be measured at the present time. It's like you borrowed 1,000 ringgit at year 0, you are expected to repay an amount worth 1,000 ringgit at year 0. That is why the net present worth should be equal to 0. Another way to see this is if we convert the annual series to become an equivalent present worth, it becomes inflow of money. So based on the definition of the rate of return, the outflow of money should be equivalent to the inflow of money. Okay, so that is why the total present worth would be equivalent to 0. So the same concept applies when using the annual worth analysis. Okay, let's look at an example to make it clearer. The first step, as always, is to draw the cash flow diagram. Very important. We know our timeline is for 10 years, so the recommended initial investment is $200,000. So as we are investing money, so money goes out, that is why the arrow is pointed downwards. They expect that with this investment, they can save up to $15,000 every year for the next 10 years. So that's our annual series from year 1 to year 10. Also stated that there are additional saving of $300,000 at the end of 10 years. So based from this information alone, we need to identify what is the expected rate of return based from the investment they made. Okay, looking at this cash flow diagram, we know that we have 3 types of cash flows. The present worth of $200,000, the annual series of $15,000, and also the future worth of $300,000. So we need to convert all this value into an equivalent present worth. So present worth, or PW, is equal to P. We don't need to multiply this with any factor as it is already in present value, and then we need to add up with the next cash flow. Let's take the annual series and multiply with PA factor to convert it into equivalent present worth, and finally we add up with the final money, and we need to multiply it with PF factor to convert it into equivalent present worth. So complete the remaining equation with N for 10 years duration. Remember, the present worth value should be equal to 0. So let's put 0 over here. In order to solve this, we have to use an estimation procedure to identify a good starting point from which interest rate we should start at. In this estimation procedure, we take the outflow of money of 200,000 as P, and as for the inflow of money, or the arrow pointed upwards, we will just total the annual worth and final worth together without considering the conversion factor. So by which 15,000 multiplied with 10 times of 15,000 and plus with the final 300,000. So we will get 450,000 of money coming in. Remember, outflow of money should be equal to inflow of money, so the P should be equivalent to F multiplied with PF factor. Substitute the amount appropriately and you should get the estimated PF factor to be 0.44444. The next step is to look up for this value in the compound interest table. So let's look out for the 0.4444 value for every compound interest table. Check on the PF column for N equals to 10 years, and you will notice that 0.4444 would be in between table 8% and table 9%. Let's say we take up the higher value of 9% interest rate and substitute this into our main equation. We will get the overall value or the overall present worth to be $22,986. That's a bit too high compared to our expected zero value. But then that's okay because this is just our first estimation. At least it gives us a good starting point on deciding the interest rate. Looking at this, we need to ensure the PA and PF factor gives smaller amount than the 9%. So you remember the PF factor gets smaller with increasing interest rate. So our next estimation can be based on a higher interest rate percentage, which is 10% or higher. So let's just take the higher rate. Let's say we'll take 11%. So our new present worth would become negative 6002, which is a bit too low than the expected zero value. But don't worry, you don't have to recalculate it again. What you can do now is to interpolate between these two values to get the final estimation if the present worth is zero. How to do that? Okay, so basically we know 9% gives a value of 22,986, while 11% of interest rate gives a value of negative 6002. So we can predict the value of rate of return by using interpolation, or we use the equation of line slope. Okay, remember equation of line slope, y2 minus y1 divided with x2 minus x1. So if you put in the values appropriately, then you will get the rate of return to be 10.58%.